Hi all, my name is Farouk Hanoun and I work for AnsTutors, and today we're going to solve this mechanical engineering problem. So for this problem we have a block as shown here. This is our block and we're told this is a 10-pound block. The weight is 10 pounds and it has a speed of 4 feet per second, and the force applied is given by this function 8t squared in pounds. So this is the force applied, and it's applied to the right. The block moves to the right, so it moves along the x-axis, x direction. This is the y direction. It's positive, positive, and we're given the coefficient of kinetic friction is 0.2, and what we want to determine the velocity of the block when it moves a distance s of 30 feet. So what is the velocity at a distance of 30 feet? So in order to do this, what we have to do first is apply Newton's laws of motion. So initially, we want to draw the free body diagram, and it is free from all the supports, and consider all of the external forces and apply the equilibrium equation to find the normal force. So our first goal is to find the normal force. So first, this is our free body diagram. We have the force, we have the weight of the block, so it goes directly down, the weight, and we know there's accelerations occurring in the positive x direction. So we're going positive x. Since it's going this way, we have a force of friction that's counteracting where the block, the direction of the movement. So the force of friction would counteract that. That's why it's going to the left. And lastly, we have a normal force because it's on a surface. So what we want to do first is apply the equilibrium in the force equilibrium in the vertical direction. We know F equals ma, so we're doing this in the y direction. So assuming positive is up, we sum the forces in the y equals to mass times acceleration in the y. So in the y, we have this n, positive n, minus the weight going down equals to mass. We know mass equals weight over gravity. So we're going to simplify this to weight over gravity for mass times ay. So n is the normal reaction gravity, g is the acceleration to the gravity, ay is the acceleration of the block in the vertical direction. But since the block moves in the horizontal direction, we have no acceleration in the vertical direction. So ay will become 0. As pictured, we have no movement. The block only moves in the horizontal, so it doesn't fly up. So ay is 0. So then we simplify this. We plug in our weight, which is given to us to be 10 pounds for W, equals to 10 for W again, divided by G is going to be our 32.2. We're looking feet per second squared. We're looking in imperial units, and times 0 for ay. So this portion goes to 0 because we're multiplying by 0 since the acceleration in the y is 0. Then we can solve for n, and n is going to be simply 10 pounds. So n is 10 pounds, and we can proceed. Then what we want to do is apply the force equilibrium in the horizontal x direction. So sum the forces in the x equals mass times acceleration in the x direction. So in the x direction, we have F, we have the applied force F, we have this force of friction, so positive F minus force of friction, equals to the mass is going to be W over G, and the acceleration in the x, A sub x. Then we know the force was given to us to be in this function, 8t squared. So we plug that in here for the force, 8t squared. Minus force of friction, we know force of friction is going to be us times n. So this is the equation for the force of friction. So us is the coefficient of kinetic friction, which is given to us, and we know n, equals to the weight over gravity times a of x. So our goal here is to solve for a of x. So we want to determine the acceleration of the block in terms of t using the equation of motion. So we solve for a of x and we get this. So after having our a of x, we plug in all the variables that we know, all the values. So gravity is 32.2, mu of s, coefficient of kinetic friction is 0.2, n is going to be 10, and w is going to be 10. The normal force was 10 as we determined. Then we can further reduce this and we get this equation for a of x, acceleration in the x direction for the block, the only acceleration. Then we can proceed. Now we want to use the velocity. We know the velocity of the block can be calculated by integrating the velocity equation. So dv equals a dt. So we can integrate these to obtain the velocity equation. Once we integrate dv, we only get v. So to do that, we're going to integrate from the interval of 4 feet per second to v. So we're doing from 4 feet per second because the block is initially at 4 feet per second to v, where we want to, so we're ending at some velocity v, and that's the velocity we're essentially looking for. So what we do here, the integral of dv is going to be simply just v, and we're doing from the interval of 4 to v, equals to the integral of 0 to t. So we start at 0, the times t 0, and we're looking to end at t. So from the interval from 0 to t. So we integrate this, you simply apply the power rule. For example, 8t2. The integral of that with respect to dt is going to be simply 8t2 plus 1 divided by 2 plus 1. And this would equal 8t to the third over 3. And that's how we get this. Then you do the same for negative 2. The integral of negative 2 is negative 2t. Then this is a constant, so we can just bring it out. And that's what's being done here. We brought this out and we integrated this portion. And we're doing from 0 to t. So once we simplify this, the way it's done, the way we get this, we do the v. So we're doing this first, this diagonal. So v is going to be simply v. Then minus, we plug in the 4 for v. And that's how we get this. Then you do the same procedure for this. And the second portion would simply be 0. So you plug in the t, which is going to be just this, minus 0. That's why we only have this. So you simplify this, then you can solve for the v, the velocity, and we get the function in terms of t to be this. Then we know the displacement of the block can be calculated by integrating the velocity equation. So we integrate these. So the integral of ds is going to be simply s. Then we integrate this side from an interval of 0 to t. Integrating this gives us this. Then we further reduce this and we get an equation for s to be this as a function of t. So after determining that, we can plug in, we know we've stated that we're at s 30 feet, a distance of 30 feet. So what we want to do here is plug in 30 feet for s, and we can, using this equation, we can simply solve for t, and we get t to be 2.0089 seconds. So after determining our t, we can proceed and we can go back and use our velocity, equation 1, and plug in t, which was this. And this is what's done here. We plug in our t and we get a velocity. Once we do our t, shown here and here, we get a velocity of 60.667 meters per second. And therefore, this is the velocity of the block at a distance of 30 feet, which is going to be 60.667 meters per second. Oh, sorry. The units are feet per second. Yes. That's all. Hope that helps. Thank you.